Hello and welcome to another lesson. Today's lesson is the beginning of a new unit on logic. So we're going to be moving away from the calculation side of this course and more into the, thinking side, for lack of a better definition. So logic, thinking about how if things make sense or not, or if something follows logically from something else. So let's get right to it. What are we going to learn? We're going to learn about simple, compound, conditional statements, biconditional statements, inverse, converse, contrapositive, and then we're going to be wondering about conjunction, disjunction, and negation, which are actually come up really early. These are actually conjunction, disjunction, negation are related to and, or, and not. But I'm getting ahead of myself already. Let's get to that when we get to it. And finally, constructing truth tables for these statements. So before we get into anything, we're going to have to define what a statement is. And that's the first thing we're going to do in this lesson, but I'm just doing some overview right now. So what are the topics going to be for this whole unit? Well, first of all, define what logic is and how we're going to deal with that. Truth tables. So kind of letting a structured method help us think through a problem involving not and an or. Not and an or, we're going to find out very soon, are called connectives. They connect two or more statements together. We're going to do other truth tables, which are, we don't even know what a truth table is yet, but this idea of NAND, NOR, and XOR are directly related to and or. We'll see this soon enough, and then we're going to see other types of statements called conditional and biconditional. Conditional and biconditional are closely related to the idea of if-then statements. So if you've ever written a piece of code and said, if this is true, then do that, then you already know what I'm talking about. For example, if x is less than 3, then increment a variable by 1, or something like that. It's very common in computer logic to use conditional statements. Statements that are only followed through on if a condition is met. But again, getting ahead of myself. Over here you'll see Mr. Mega Man dealing with his own little logic problem. Direct hits from missiles and bombs, little damage. Spikes, instant death. So anyone who's played Mega Man can relate to that. Although the logic isn't necessarily sound. It's not logical. Someone might say that in casual terms. That doesn't make sense. It makes no sense. But we're actually going to formalize logic in this unit and see if something like that is actually a logical statement or not. I might actually not come back to this, but you can go back to it and think, does this relate to what we're doing or not? So let me just finish my overview here before I get into specifics. Computers can do more than calculate. They can figure things out for us. They can make logical decisions. Specifically, they can decide if something is true or false. And we kind of brushed this idea before, true being 1, false being 0, true being on, false being off. So there's a direct correlation between what we're going to do in computer logic. So it says we're about to study the fundamentals of math logic, which will lay the foundation for computer logic. All right? Logic is the science of reasoning, so figuring things out, essentially, where certain statements are either true or false. The two possible outcomes are easily adaptable to the binary system. Once again, true is 1, false is 0. And we're going to be dealing a lot, eventually, with logic gates, like this. This is a logic gate, which means you take two statements into it, for example, input A and input B. Something is decided, maybe they both need to be 1. Maybe both statements need to be true in order for the output to be true. We'll get to that later, but basically the idea is that two things come into a gate, one thing comes out. And that's all that this logic is about, putting statements together and seeing if the final statement makes sense or not, or at least if it's true or not. So let's see what we have here. Logic is the science of reasoning if a given statement is true or false. All right. A statement is a declarative sentence that is either true or false, but cannot be both. So if it's a statement, then it cannot be both true and false. It has to be either true or false. So they can be extremely complicated or extremely simple, but we only care about if the overall idea is true. So you can say true is 1, you can say false is 0, you can relate it all the way back to this binary idea of on and off. But really it's like, I could say, it's raining outside. And you could say, no it's not. And if you can say that, then I've at least made the statement. You've said if it's true or false. If I just say, brown, you can say, that doesn't make sense. I can't say if that's true or false. All you did was say a color. So let's actually formalize what a statement is with the idea of simple statements. So a simple statement is a statement with no connectives. Connectives being and, or, not. But I'll get to that later. So this first exercise, are these simple statements? In other words, can they be said to be true or false? True or false. So the first one, the store is open. Think to yourself, the store is open. Can I say, yes, that's true, or yes, that's false? You can, of course you can. The store is open, yes or no, it either is or not. So yes, that's a simple statement. When is the game? Can you say if that's true or false? When is the game? No, because that's a question. So you can't say true or false, it's a question. So we say no, it's a question. Now in the brackets, you wouldn't actually need to include that. Let me actually write that so it's legible. You wouldn't need to include that part, but that's why it's not a simple statement. It's a question. 3, Warzone is the best COD game. So you can either agree with that and say it's true, or you can disagree and say it's false. But for sure, that's a simple statement because you can say if it's true or false. You can say true or false. You can give it a true or false value. 4, get active. Or if it was Mega Man, get equipped. That is not a simple statement. You can't say it's true or false. That's just what I would call a declaration. You're just saying something, and it's an exclamation, a declaration. It's certainly not a statement. Math is awesome. Yes. And I'm saying yes because it's a simple statement. You can say true, math is awesome. Or you can say false, math is not awesome. But in any case, you can say if it's true or false. The selling price? No. It's not a simple statement because you can't, it's just words. You can't say true, the selling price, false, the selling price. It makes no sense. And finally, a binary digit is either 0 or 1. That's definitely true, but the important thing is that, yes, it can be said that it's true or false. Right? So hopefully this is making some sense to you. A simple statement, if it can be said it's true or false, yeah, it's a simple statement. Let's check our understanding here. I recommend that you take a look at this and maybe pause the video, read it through, and see if you can do it yourself before I finish. Okay? I'll go through this, but give it a shot. Maybe you already understand this without me explaining it. So state if the statement is true, false, or neither. And if it's neither, we call it invalid. So P, 5 is greater than 2. Is 5 greater than 2? Yes. True. You could give it a T value. P, 2 greater than 5? No. No. It's false. And in the last case, X is greater than or equal to 2. Well, in this case, we don't know if X is greater than or equal to 2, so we would say neither. We haven't been asked if it's a statement, we've been asked if it's true or false. And there's no way for us to know if it's true or false if we don't know what number X is. So just something to write down if you feel like it. Let's keep going. Let's see what else we can accomplish in this unit. Ooh, compound statements. Well, a simple statement was something that could be said it's true or false. A compound statement is a statement with one or more connectives. And the connectives are and, or, and not. So I'm going to go to the video store. I'm going to go to the grocery store and buy potatoes. That has an and in it. So I am going to go to the grocery store and I am going to buy potatoes. That's a compound statement. And it says we will use symbols to represent each statement, usually the letters P, Q, and R. Those are just standard, okay? Those are just standard letters that we use Very common for logic to use the words P, Q, R, to use the letters P, Q, and R. So to be specific here, we have an example that says, an example compound statement, which says, the sky is blue and I am happy. It's a compound statement that can be written as P and Q. And the reason for that, I'll just highlight it to be even more obvious. This part could be P. The and has the form, it looks like this. It's called a conjunction. It's a little hat. And then Q. Now I don't have a green highlighter, but I'll bring one up. I am happy. That would be our Q piece. So we can see it actually is saying P and Q. We've what's called formalized the statement. We've turned our English into letters. And we're going to be doing that a lot. Okay? So it says in the last piece here, we are going to consider the three connectives: conjunction, disjunction, and negation. Conjunction means and, which has the symbol of like a hat, a little tent. Disjunction is or, which looks like a V, and negation, which means not, which is this little tilde, or sometimes there's other ways of writing it. Sometimes it's P with a little apostrophe. Sometimes on computer it's this this symbol, or you can even do, there's sometimes even a bar on top, but the most common is to use tilde. A lot of students forget which one's which here, which one's conjunction, which one's negation. So remember, and looks like the little hat. Okay, maybe I'll write that in black. So and looks like the carrot or the tent, or looks like this. The way I remember this is I take a look at the and symbol, or I took a look at and. That A looks an awful lot like this does. So it's almost like it's telling you, hey, this symbol means and. Just something to try. That might help you understand it, or might help you remember it. So let's do an exercise with conjunction. Remember, the symbols are up here if you forget. Conjunction means and, also has the symbol that represents and. Write the compound statement using symbolic logic. So that means write using P, Q, R, and your connectives. Okay, that's basically what it means. Symbolic logic, I mean. The gas prices go up and the savings account goes down. Isn't that just the truth? So the gas prices go up and the savings account goes down. I would say that this is P, you can call this P, and has the symbol like this, and the savings account goes down. We could just call that Q. Or you can call it, you could call it G and S if you wanted. It makes no difference. I'm just going to be standard and say P and Q. So yeah, the final answer is just P and Q. That is the answer. That's the whole thing. Now, if you wanted to be very specific, it would probably be a good idea, just so that it's clear, at least when you're first learning this, to write out what each piece is more clearly. So I'm going to do that just so that I have the question completely done. So we can see that I've formalized it in terms of P and Q, and then I've written the final statement, this one being basically the final answer, and that's it. So you can see, hopefully, that it almost works as its own equation. It looks similar to an equation. It's not an equation really, it's a statement, but you can move these things around. You could do Q and P instead of P and Q and just move things around, see if it still makes sense. But for now, we'll just start small. Let's try disjunction. I recommend that you pause the video and see if you can get the answer to this one. This one is pretty straightforward. Oops. This one's pretty straightforward, so pause the video and see if you can get it. Alright, so I'll write out my answer for this. So you'll see that I have P or Q. I've done the formal symbolic logic, which is using the or, also known as the disjunction, also known as or, and now I'm going to write out formally what each piece actually is. All right, so I've written down the statements. I also included the connective this time, just to be specific. The connective is or, and then the final answer, P or Q. So a couple quick notes. Each of these individual pieces, this and this, P and Q on their own, they are simple statements. I should write it here. So we can see that we can connect simple statements with connectives, that's why they're called connectives, and create a longer compound statement, which can also be said to be true or false. And we can link them, we can make huge statements if we wanted to, made up of individual simple statements connected by things like connectives. So we have one more situation here called negation. So negation is not, also tilde, sometimes written as this weird little symbol here, which I don't know the name of. And I also recommend here you pause the video, see if you can figure this one out. Okay, hopefully you've paused and give it a shot. It says, write the compound statement using symbolic logic. It says the octopus is not smart. Well, if you've seen The Octopus Teacher on Netflix, which I recommend, they are smart. But it doesn't matter if this sentence is true or false. What matters is that it could be said to be true or false. So the octopus is not smart. So there's like something weird going on with this one. The not, the negation is in the middle. So this is our tilde, but the blue part is really our statement, okay? So let me just write this out more specifically, and you can see what we're dealing with. So the statement really, if we remove the connective, and in this case it's not really a connective, but it's called a connective, the negation, we remove the negation and we end up getting the statement the octopus is smart. And then we would negate that and say the octopus is not smart. And the reason we put it there is obviously just English rules. We can't say not the octopus is smart. You know what I mean? You can't put the not at the beginning. It makes no sense. So even though the statement is split up by a not, in symbolic logic, we would write not P. So if P is the octopus is smart, then not that is the octopus is not smart. So hopefully you can make sense of this. Most of you are English as a first language speakers, so I don't think this will cause too much issue, but I hope that it's making some sort of sense. So far we've done and, or, and not. Let's do a little bit of mixed exercises here and see if we can figure this stuff out. So I recommend once again that you pause the video just to see if you can do it yourself, and then unpause the video and see what I've done. Okay. So write the compound statements using symbolic logic. I did not call my mother this week, and she is angry. So maybe you can relate to this. I don't know. Maybe it's not a personal situation. Anyway, I did not call my mother this week. I did not call my mother this week. Okay, that would be our P. And. What's our symbol for and? Is it this or is it this? Let me put this down here. Well, it's the one that looks like an A, correct? That means and. That's our disjunction. I believe it's just disjunction. I always get those two mixed up. Let me just look at my notes. Yeah, conjunction. No, conjunction. So right away I made a mistake. Conjunction and disjunction. I got to get a handle on those. Maybe conjunction is C, comes before disjunction D. A comes before or. I don't know. I always mix it up. But and, she is angry. She is angry can be our Q. So it's obvious what our two statements are. So I'm just going to write P and Q, and if you were asked, you would say that P is this statement and Q is this statement. But in the interest of time, I'm just going to write out our final statement as P and Q. Let's do the next one. My jeans have shrunk. That could be said to be true or false, so I'm going to say that's our P. I see or. Okay, or is our disjunction, which has this V symbol. Or I ate too much and I gained weight. We have something weird going on here. Or I ate too much and I have another disjunction. I have another connective and in the same statement. So we've already used P and Q, this being P or Q and R. We're going to call this R. We have three simple statements connected by connectives. So let's write this out. Let's write this in formal symbolic logic. P, or, Q, and R. Now, it turns out that even if you got this far, there's something important about the comma going on here. There's a comma in this question, which is actually meaning that some of these statements are like connected to each other, not just by connectives, but logically connected. So I'm going to read it again. My jeans have shrunk, or I ate too much and I gained weight. That's how you read this. Or I ate too much and I gained weight. What that means in logic is that these connectives, simple statements, this compound statement, or this section of the compound statement, is grouped. Because you kind of have two situations here. My jeans have shrunk, or I ate too much and I gained weight. Right? It's either this first piece or it's this whole other piece. And you got to be careful, right? When you're reading the question, especially when you got three statements like this, be careful with your brackets use. So I've just said, read the statement carefully to determine where to put brackets. Just be careful and put the brackets where they're supposed to be, right? Make sure it makes sense. Concept check. Translate the symbolic logic into English. And this looks a bit crazy, but let's just think about it. What is it? What the heck am I trying to say? It says that is the question. What is that? Let's read it out. Well, to be. To be. To be. Or. Not to be. To be or not to be. That is the question. Oh. Yeah. Okay. To be or not to be, that is the question. That is silly. So, I just kind of trolled you there. It's just a joke. But if you understand connectives, I'll just clean this up. If you understand what connectives are, then you know that this is or and this is not. And then, you can make these terrible jokes with your friends, whether your friends like it or not. So it's kind of nice to have a little extra tool in your toolbox, I guess. So the next section is practice. I recommend you just stop here, pause the video, try all these. You have all the skills you need now to be able to handle all these questions. And then once you've paused the video and gave it all a shot, give it an honest try, because you're not really going to learn as much if you don't give it a good try. Come back here and then see what I say about it. So determine whether the statement is simple, compound, or neither. Simple, compound, or it could just not be a simple statement or a compound statement at all. So 3 different options here, and I'll just write out what the answers are here. I worked late and I missed the bus. It's conjunction, has an and. Open the safe. Neither. It can't be said it's true or false. The car is red. Can be said as true or false for sure. The door is not open. This one's tricky. What is it? It's a compound statement. And it uses not. So what I should have said in the first question, actually, 1A, I worked late and I missed the bus. I should have written this differently. So it uses and then to be clear in the last question, it uses not. Okay. It has a connective. It has a connective. That's the important thing. Compound statements have connectives. So question 2, write the statements in symbolic logic. Set P equals I went to town, Q means I had lunch, and R is I met Fred. So I went to town and I had lunch. That would be P. Let me get my colors normal. P and I had lunch. So P and Q. B, I had lunch or I met Fred. That's Q or R. C, I had lunch and I did not meet Fred. So I had lunch, that would be Q, and I did not meet Fred. So if R is I met Fred, I did not meet Fred. So not R. And finally, D, I did not go to town and have lunch. Well, the way I think about this, and this is another tricky one, is you can go to town and have lunch. So I went to town and I had lunch. If you did not do that, then you did not go to town and have lunch. It's the go to town part is grouped, and you didn't do any of it. So normally you'd go to town and have lunch. If you didn't go to town and have lunch, then it's not P and Q. So just be careful once again with the brackets. And if you have any trouble with that, you got to make a note of that and just let me know. I'd be happy to go through this question again with you. Let's finish this off. Practice. Write the symbolic logic statements in English. Now, writing things in English takes some time, and I get that. So take your time and make sure you do it right, okay? Make sure that you've written these questions down correctly. So pause the video if you need to, and come back here to see how I handle this. So 3A, I had lunch. This is what I would write for this. All right, and the reason I say that is I did have lunch, and then I did not have lunch. So you have basically Q, or pieces of Q, being the blue, and then the not. And again, it's just a negation of having lunch. And you can write it different ways. You can think of a different way of saying that. Like to say I did not have lunch, you can say it. It would still mean the same thing. You'd still get the mark for it. Let's try B. P and R and not Q. So this is what I would say for this. Okay, and I like to just write it in simple English. You can be more formal, you can be less formal. As long as you're still getting the same logic across, it's okay. So let's piece this together. I went to town, that would be my P part, and met Fred. So met Fred is R. But didn't have lunch. Well, but. I should have said and. Don't know why I said but there. Well, I will explain why I said but in a second. So another and then we have not Q. So once again, have lunch is Q. I had lunch. And then didn't. Well, did not. Okay? So this is our two of our conjunctions and then a negation. So notice you could have written this a different way. You could have written it the way that I wrote it first, which is I went to town and met Fred and didn't have lunch. Or you could write it, I went to town and met Fred but didn't have lunch or did not have lunch. There are many ways that you can write this, most of them being equivalent or correct. Just be really careful that you're actually writing what you think you're saying. So I'm just going to write down below it exactly what each piece is. And hopefully you're convinced to some extent that I did actually write down what I said I was writing. Now the last one, once again, has brackets in it to begin with, but now we need to write it in English. So definitely take some time to try this one before I give you the answer here. You know, mull it over in your brain, see if you can get it before you see my answer. Okay, can you see where I made the mistake? There's brackets that I didn't get across in my English statement. So really when I see this here, there's an or, something or, and then you have this and. So the way I look at this is I went to town or, and I kind of think this in brackets, but that's not how English works. You don't write brackets in that way. It doesn't work like that. It's not like math. So our own way of using brackets in English is usually comma. So I went to town, and I'm going to put a little comma there. I went to town, or I met Fred and had lunch. All right? The comma is essentially the English way of using brackets. All right? It groups our ideas. I went to town, comma, or I met Fred and had lunch. So you either went to town, or you met Fred and had lunch. The met Fred and had lunch is like a package deal. You can't do one without the other here, okay? And let's not forget, every single piece of this is made up of simple statements that can be said to be true or false. For example, I went to town is a simple statement. I had lunch is a simple statement. I met Fred is a simple statement, and they're all broken up by connectives. They can be made fancy with brackets and whatever else, but at the end of the day, it's just simple statements made up of connectives, and you can still say whether or not the entire sentence is true or false. All right, so that's what we're getting at here. So that's the end of this lesson. Hopefully it wasn't too boring or long. In fact, I find this very interesting, and it will be, I feel like this unit even just gets more interesting as we go. This and the next unit are quite interesting, but to each their own. But I recommend that if you want a little more insight into this topic, you watch this video. It's only 6 minutes long, 6 minutes, 18 seconds. And this guy, he's a little bit weird actually, but I kind of like him. I don't know, maybe we're kindred spirits. Take a look at it, watch the video, and see what he has to say. It might be a good idea. The next topic that we're going to cover in this unit is truth tables. We're going to organize our ideas into a nice logical table and see what the truth value is going to be. But that's for another lesson. Thanks for watching and have a great day. I'll see you in the next lesson.